In this video, we're going to take a binomial, x plus 3, and we are going to expand it out to the fifth power. So we're going to use the ideas that we talked about in the previous video with our combinations as our coefficient of the term. We're going to look at to see how the first term x develops as we look across this pattern, and how the second term 3 develops across this pattern. Okay, so let's start with the coefficient. We've got 5 of 0. So that's saying we've got 5 items. We're taking 0 of them using our combination notation. That will give us a constant value that we'll use for our coefficient. Then we look at our first term, x, and we're going to take that to the fifth power. And we're going to take our second term, 3, and we're going to take that to the 0 power. And then we're going to add to that n of 1, or 5 of 1. That's going to give us, again, our coefficient, a constant for our coefficient using combinations. And we are going to multiply that by x to the fourth power and 3 to the first power. And we're going to follow this same pattern all the way out. 5 of 2, x cubed, 3 squared. 5 of 3, x squared, 3 cubed, and so on. So you should notice a nice pattern developing here. First, for our coefficients, for our combinations, we start at 0 and we increase our r value with each multiplication, with each time that we go. Also, you'll notice that our x coefficient decreases by 1 with every step of the way. Decreases by 1 all the way down to 0. And finally, our second term, the 3, it increases as we go. So we increase the entire way, all the way up from 0 to 5. Now the other thing that you probably notice is that our exponents in each one of these is adding up to 5. So 5 plus 0, that equals 5. 4 plus 1, that equals 5. 3 plus 2, and so on. So this is a common pattern that you're going to see when you expand these out a little bit. So you're going to see all of these patterns repeat themselves. Alright, so let's do some simplifying. Using your calculator, you can say 5 of 0. You can put your combination in there, or you can use the factorial notation. But we're going to find that is equal to 1. Simplifying a little bit further, x to the fifth and 3 to the 0 power is 1, so we don't need to put anything there. Plus 5. So 5 of 1 is 5. Again, this is going to just follow Pascal's triangle. It's going to follow combinations. You're going to want to do these on your calculator as you go. 3 to the first power is 3, x to the fourth power. Plus 5 of 2, which is 10. We have 3. Now, although it looks like it, keep in mind this isn't 5 times 1 and 5 times 2, right? As you'll see, the pattern changes, and you're going to see that you're not just multiplying these two things together. So keep that in mind. So now we have 3 squared, so we've got 9, or 3 squared. We'll simplify it a little bit further in a second. And x cubed plus 5 of 3, that's going to be 10 again. We have 3 cubed, we have x squared, and then we have 5 of 4, which is 5. 3 to the fourth power times x, and then finally 5 of 5, which is 1. X to the 0 power is 1, and 3 to the fifth power. Okay, so now we just have some basic multiplication to do. We got x to the fifth power plus 15 x to the fourth power plus, what is that, 3 squared, which is 9. 9 times 10 is 90, x cubed plus 3 cubed times 10, which is 270, x squared. 3 to the fourth power is 81. 81 times 5 is 405, x. And then finally we have 3 to the fifth power, which is 243. So there we go. Expanded out nice and neat. Not the most complicated of processes, but definitely a lot of steps in there, a lot of places to make some simple mistakes, but you get the idea here. So let's look at another. 2x minus 5y cubed. Alright, we're going to go through the same process, but now instead of 5, we're going to the third power. We're going to the third power. So we got 3 of 0. Our 2x is going to go to the third power. and our negative 5y is going to go to the 0 power, plus 3 of 1, 2x squared, and negative 5y to the first, plus 3 of 2, 2x to the first power, and negative 5y squared, plus 3 of 3 times 2x to the 0 power and negative 5y to the third power. Expanding out, we know 3 of 0, that's going to be 1. 2x cubed, so that's everything inside the parentheses. 2 times 2 is 4 times 2 is 8, x cubed, and then we have our negative 5y to the 0 power, so that's going to be 1. 3 of 1 is 3, 2x squared, so that's going to give us 4x squared, and negative 5y, so we're going to have a negative 5y. Plus 3 of 2 is 3, 2x times 2x, times negative 5y squared, which is positive 25y squared. And then finally 3 of 3, which is 1, 2x to the 0 power is 1, and negative 5y is negative 125y cubed. Again, just doing some basic computations. 8x cubed plus 3 times 4 is 12 times a negative 5. That's going to be negative 60 x squared y. Then we have 25 times 6. 25 times 6 is a positive 150 x y squared. And then finally we have a negative 125 y cubed. So nice and easy. Hopefully you're getting the pattern here. All right, so now here's something a little different. I want to find the x cubed term, in the binomial 4x minus 1 to the 9th power. Okay, so now we're going to have to look at the patterns that we've recognized up above. So we're looking for the x cubed term. So we know we're going to go 4x to the 9th power, so we have to figure out which term number this is. Well, if we look at above, we have 10 terms if we're taking it to the 9th power. Now, how do I know that? If we look in the first one, we had the x plus 3 to the 5th power, and we ended up with 1, 2, 3, 4, 5, 6 terms. When we had 2x plus 5y to the 3rd power, we had 1, 2, 3, 4 terms. So we're going to always be we're going to have one term more than the exponent or the power that we're expanding out. So now we have to go down to x cubed. So we've got 4x to the 8th all the way down to 4x cubed. So how many terms is that? Well, 9 is 1, 8 is 2, 7 is 3, 6 is 4, 5 is 5, where are we at? 4 is 6, and 3 is 7. So this is our 7th term in the sequence. 7th term if we're going from the left. Now, we saw with our coefficients also met a pattern. So we could go from the left or we could go from the right. So if we counted from our x to the 0 power, 4x to the 0 power, we would go 0, 1, 2, 3, and it would be the 4th term from the right. So either one of these, you can go from the left or the right, whatever is more convenient for you, whichever works easier for you. Okay, so that means we're taking 9 of 0, so we have to make sure that we have the right coefficient. So if 9 of 0 is our first term, and 9 of 1 is our second term, then our r value, the 0, the 1, that's going to be 1 less than the term that we want. So we're going to go down to 9 of 6. So we take 9 of 6, and or we could take 9 of 3 if we're going from the right. It's going to be 1 less than the term. So either one of those can be used, and we'll get the same coefficient. Okay, so let's see, 9 of 6 or 9 of 3. So we'll take 9 of 6. 9 of 6 and times 4x cubed, And then don't forget about the -1. So we have to make our cubed power match our -1 power. So that means -1 is going to be to the 6th power, right? 6th power. So because we're taking 3 plus 6, and that has to equal 9. It has to match up there. So 9 of 6 is 84. 4x cubed. So we got 4 cubed, x cubed, and -1 to the 6th power, multiplying it out. 84 times 64 times a +1 x cubed, and that whole thing is going to give us 5,376 x cubed, and that is our final answer there. So hopefully that logical reasoning helps you get to the term that you're looking for, and hopefully that all makes sense. And we will talk to you in the next video.